Hello and welcome to this complimentary webinar in the Sartorius Stadium Data Analytics Solutions series of complimentary webinar. This webinar has the title Discovering the Geometric Suite of Data Analytics Solutions, and we are today going to watch part 9, looking into the data analytics capabilities of the Simca Online system. The subtitle is Using Advanced Data Analytics Models in Real Time, and the presenter today is Senior Data Scientist Anna Persson. She is based in New Jersey and covers the whole North American market for the geometrics business within Sartorius. So Anna, tell us your story, please. The word is yours.
Thank you, Lennart. Welcome to this webinar. Today we're going to talk about Simca Online, which is one of the components of the geometric suite of data analytics solutions. I know some of you who have been following the webinar series have seen presentations with a lot of the other components of geometric suite. We have MODI, which is the design of experiment software. We have EC Analytics, which is a rather new tool of the geometric suite, which can do some univariate analytics. We have Simca, which is the offline multivariate software tool. We have Simca Online, which is the real-time execution engine for models that have been built in Simca, and that is the component of the geometric suite that we're going to focus in on today. Then there's the Control Advisor, which comes up in the next webinar, which is a supervisory control tool for multivariate model predictive control. And then there's the active dashboard. So these are the components of the geometric suite, and like we said, today we're going to focus in on Simca Online. Here you can see the contents of today's presentation. We're going to start out with an introduction to Simca Online. We're going to talk about Simca Online system design. We're then going to go into how to use Simca Online and top that off with a live demonstration of the software. After that, I'm going to show a few user testimonials, a few case studies from other customers that are using Simca Online today. And then we're going to finish with a conclusion and, just like Lennart said, some Q&A at the end. So, an introduction to Simca Online. Many times, the reason why companies embark on using Simca Online is they worked with Simca for a while. They have perhaps built models of their processes, which characterizes either batch or continuous processes. And they have a lot of data that they are collecting in real time and that they are gathering in a historian and storing there. And they want to utilize all the benefits of this data. Using Simca Online is a very good way of taking advantage of all of the data that is collected in the process and utilize it to turn it into a benefit for the operations. And detecting process issues is a very big use of Simca Online in order to boost business growth in the end. It could be that we want to minimize operational costs. It could be that we want to increase confidence in process performance and thereby increase confidence in product quality. It could be that we are looking to maximize efficiency throughout operations, but also in the way that we monitor our processes. The reason why it is efficient to utilize a tool like Simca Online is that it utilizes multivariate technology that basically summarizes all our individual parameters into multivariate parameters that we then use to monitor the process in real time. And we can then get basically a trace of the process which contains an input from all of the original process variables. And for those of you who have followed the webinars and studied multivariate methods, you know that a score, for example, over time will contain an input from all of the original variables, and thereby it becomes very efficient in the control room because you can, by looking at a small set of multivariate summary parameters, you're actually monitoring all of the variables at the same time. So it becomes a very efficient solution. You don't have to make sure that you're looking at individual key parameters because you're actually looking at them all at the same time. And also then, of course, at another big advantage of using multivariate monitoring technology like this, such as Simca Online, is that you are also using correlations between variables as an advantage and as a tool to basically increase the sensitivity of your system to pick up changes in the process that may happen. And also for many other applications, to utilize correlations between variables as a part of this monitoring system is a great advantage. So with this at our fingertips, we will have functionalities like remote monitoring. It will be possible to monitor the process and to connect in from various different locations throughout the organization to view the process. And so it actually also is a very big, objective is just to increase awareness and visualization of the process throughout the company. Multivariate predictive monitoring can be an objective. Of course, real-time multivariate fault detection of a process is an objective. Doing then root cause analysis for whenever a fault is detected. There are also possibilities within Simca Online now with a control advisor to do automatic corrective recommendations and also possibly for closing the loop. And this subject of real-time process control, like I mentioned, is going to be covered in the next webinar by my colleague, Chris McCready. So what can Simca Online do? Well, basically, you can divide the functionality of Simca Online in different ways. But if we look at it from a very basic level, we can, in Simca Online, employ models from Simca, both batch evolution models as well as batch level models, if we're looking at batch processes. Simca Online actually functions both for batch processes as well as for continuous processes, and we're going to see that in the demo. If we focus in on the batch version of Simca Online, we have one view that basically employs the batch evolution model from Simca, and here we can use that to monitor the process in real time. We essentially create a batch evolution model of our process, we upload that into Simca Online, and then we can view the process in real time. And these are the golden batch trajectories that we're used to seeing. Then we can also, in Simca Online, employ the batch level models, where we may have PLS or OPLS models or possibly PCA models, where we also have a regression relationship with some quality parameters or with some critical quality attributes of the process, where we can actually employ that in the batch level to view final quality predictions or final critical quality attribute predictions. And this can be something that can help us get an idea of what final parameters such as perhaps final yield is going to look like even before the batch process has ended. It's possible to build those sequential prediction models and employ them in Simca Online so that you can get an early prediction of what final critical quality attributes should be. So you have those two levels in Simca Online. And then there's also now the level of supervisory control, which is a possibility with the control advisor. Simca Online is proven in a very wide range of industries. Of course, it is very heavily used in the biopharmaceutical industry. Here you're seeing some quotes from customers using Simca Online. We have references within the paper industry, within food and agriculture, within pharmaceutical, within biotech, in the chemical industry, and so forth. Simca Online improves overall understanding of process and equipment, of course, because we are getting real-time information and updates on what is happening in the process right now. And we can do real-time drill down of that to get an understanding of what's happening in the process based on the data that that's being collected on it. We saved $240,000 within a year and a half. We take informed action 50% of our production batches based on Simca Online. More information, less numbers. This is, of course, an advantage with multivariate technology as a whole. Right the first time, reduction of cycle time, increase throughput by tens of tons per year. That can be another objective. Improve asset utilization, of course, reduce downtime and increase equipment reliability, because we can simply make sure that this technology supports us in avoiding that there is downtime and to detect problems with equipment, thereby becoming more reliable. So let's talk a little bit about the system design of Simca Online. Here you see the basic overall infrastructure, and we can see, and I'm going to take out my laser pointer. If we have the process here, perhaps we have a laboratory as well. Simca Online is a server client application. It is installed as a service on a computer. Usually a server computer, and it connects to a process database, such as, for example, OSI Pi. And via this database, it pulls data then at a certain execution interval from the process and into the Simca Online server. The Simca Online server also has uploaded within it a USP file built in Simca, which is then used to compare the current values that are coming from the process as a projection onto the Simca model, and then the results are delivered to a number of Simca Online clients which have been installed at various locations throughout the company. Of course, in the control room, it could also be in development and technology staff, as well as at the management level. And that communication happens through TCP/IP from the Simca Online server into the clients. The connection between Simca Online and the process database takes place through a so-called SIM API, which is an interface between Simca Online and that particular process database. And there are a number of different SIM APIs available, and you can also have multiple SIM APIs running at the same time, so that you can actually pull data from the process that lands in different data sources, so that you may have some data that resides in Pi. You may have some data perhaps that is stored in LIMS. You may have some spectroscopy data that's stored somewhere else. And there's then the opportunity to connect all of those different data sources into Simca Online and pull data simultaneously, like so. And here is a slide that shows basically the layout according to ISA 95, showing the model for integration of business and manufacturing systems and the different activity layers that we have within there, going from lower levels of the process and process control into level 3, where we basically have maintenance, production, quality departments, inventory, where we also have our process databases and our LIMS systems residing. And then we have the business operations level 4, which consists of sales and marketing of the organization and product development, logistics, MES system, and so forth. And Simca Online servers and clients usually reside in level 3. And then in level 4, we also often see Simca Online clients installed. And usually there can be a firewall here, because this level may, of course, then differentiate different sites, for example. There could also be a firewall located here, but typically Simca Online servers reside in the manufacturing operations level 3, along with clients, and then you also are going to have Simca Online clients in level 4. And to talk a little bit more about the SIM API and the different SIM APIs that we can utilize with Simca Online, that has been on the market for quite some time. There have been a number of different SIM APIs or interfaces between a data source and Simca Online developed. So here you can see a number of those in this table. We have SIM APIs for OPC. We have SIM API for IP21, for discoverance, for CSV files. There's also a batch table wrapper that is available in case batch context does not exist in the historian. Simca Online requires information about batch ID, and it also requires information about when a batch starts and stops. And if this is not available in the historian, but only continuous process data is available, then the batch table wrapper can be utilized to create this batch context. There's also an OPC ODBC SIM API. There's a SIM API for Pi, for SciPad, and SyntaQ. And some of the functionality between the SIM APIs differ, and that's what we can see here. Some of the SIM APIs that we've had for a long time that are very thoroughly tested include the Pi SIM API, as well as the SIM API for OPC ODBC. So how to use Simca Online? The basic operating principle of Simca Online on a very high level, and like I said, this can be used both for continuous as well as batch processes, is that there is a very high level sort of alarm system that is employed within Simca Online, where we can think of it in terms of a traffic light, where we have either a green signal, we have a yellow signal, or we have a red signal. As we know, Simca Online, which is a multivariate monitoring and prediction tool, multivariate techniques, yes, can be a little complicated, and so we have put a lot of effort and a lot of time into developing a tool that is applicable on the shop floor, where you do not have to be an expert in multivariate methods in order to utilize this. And this operating principle of green, yellow, and red speaks to that. We work with dashboards and overviews that basically lists units, that lists batches, and whenever we have everything operating as it should, alarms have been configured on the system to draw those lines. When everything is working well, then things are colored green. And when we have particular batches or sections of process that start to approach or go beyond warning limits, these colors turn to yellow. And when we have a true deviation, then we get red colors. So here you can see this is a continuous process that's running in Simca Online. It's being monitored. And we have this production overview here to the side where we can see that we have execution turning yellow, meaning that we have a warning. Something has gone outside of the warning limit. And then simply you just click on this and it drills you into the particular plots which are causing or which are showing the deviation. And here we can actually see that we have a number of points that are going outside of the yellow warning line and the red critical limits. So we're working throughout basically the highest level of the software in this red, yellow, green operating principle. This is a feature in Simca Online which is very, very helpful when we employ Simca Online on the shop floor. It is designed to give us an overview of all the units that we have Simca Online running on, and it is also designed according to this green, yellow, red principle, where all the units which are currently running as they should are green. All units which have displayed some kind of warning are yellow, and then all the units which have a deviation confirmed associated with them will be colored red. So each one of these individual boxes represent a physical unit in production. And then you can also see that within each unit we can see how many configurations that are running. In other words, how many different models that we are running on these different units. And you can see how many of those models that are executing. It may be that you have on a particular fermentation reactor, for example, you may have multiple models that are running, but only or loaded or uploaded and configured, but you only have a few of them executing. And then it would look something like this. Maybe 2 out of 3 models are executing on a particular physical unit in the process. And what's nice about this is that these boxes are clickable. So you can actually go in and click on any one of these, and that will bring you into a particular plot for that unit which shows the deviation. So when an alarm is triggered, just in that plot itself, you can then double click on that point to drill into the contribution. So here we're seeing a score plot where we have a deviation that's happening, and you can then double click on this point, and that will then generate a contribution plot, which allows you to see all of the original variables, puts us back into that space, and shows us which variables are the key contributors to this particular process deviation that we're seeing. You can then drill in further by double-clicking on that variable, and then get into a regular univariate SPC chart of that variable alone. So now we're back to the the units that the operators are used to seeing. So this is also how it becomes efficient. We go from that very top layer where you have multivariate monitoring of all these different units, and then you just click on whatever is showing you that you have an alarm. That drills you into the plot that's off, that drills you further into the contribution. You can click your way all the way into the particular process parameters that's out. And thereby we're actually monitoring all the variables at the same time, and whenever there's an alarm, even though we have this very sophisticated multivariate system running, we can get into a space that aligns very much with what operators are used to seeing. So now let's look at this in Simca Online. So I'm going to go into the software itself and give you a brief demo. So here we can see Simca Online running. And I'm using a simulator. We have a simulator. It's called DB Maker, which actually is available on our website. You can actually download Simca Online together with this process simulator, which is called DB Maker, where you can take your own data sets and create databases based on that. So you can actually run a simulation of your own process in Simca Online. And this is available for free on our website. So I encourage you to use this for demonstrating this type of tool, or to demonstrate Simca Online within your organization. So I am running here a couple of different data sets. And what I'm looking at right here is Baker's yeast. You may be familiar with this example that we have, which is a batch process. And I have basically three different plots open. I have the batch evolution DMODX plot, I have the batch evolution hotel T2 range, and I have a batch evolution score plot. And so I'm going to zoom in here on the score plot. And so this basically shows you for this process, for a batch process, the evolution of the batch from the beginning to the end. And the red and green limits that you're seeing here are coming from the USP file, the Simca model file that you built that characterized your process, that was already ready, and uploaded into Simca Online. So these are the control limits of the process that characterize the process, basically, or the multivariate plus minus 3 standard deviation limits on T1. So then here, the blue trace represents the process that is, or the batch that's running right now, the current batch. That's executing here on a rather quick execution interval. This is set in the software, how quickly we execute. And this should match the sampling interval that you have in the model file, in the USP file that has been built on the process. And we can see here in the production overview window, we can see the active batch which is running, and the fact that it's green. We can also see a number of historical batches that ran through here. And we can go in and click on any one of the historical batches. For example, I can go in here to this batch, which I see was red. I can double click on this red color, which is going to bring me into that particular batch that ran. And here we can see that this was the batch that was very much had a deviation, a very strong deviation, both in the hoteling T2 range and the score, first score, as well as in the DMODX. And then from there, you can double click on any point here to get into the contribution. We see that it was the ethanol that was out here. We can double click again on ethanol, and we get into the ethanol univariate plot here. And this was, of course, for a historical batch, and I took that one because I didn't have yet a deviation to click on in my current batch. I'm going to close these windows now. You can see that my current active batch here is showing yellow. And that was because we went outside of the yellow warning limit in one of these plots, and it's actually now gone to red. So now my active batch has gone to red. I can also see that in the trajectory, so I can just double click here to do my real-time drill down. Sometimes you have to be a little careful. There, I can see it's the temperature that's out at that particular time. We can see temperature is deviating outside of its own control limits. It's also possible to actually establish alarms on univariate parameters as well as multivariate parameters here. If we look at the corresponding, also we can take a look at the unit overview, which we have right here. And here we can see the different units that I have configured in Simca Online. I have 4 physical units that I've configured in Simca Online. So this is the very, very top layer then. Really, in essence, it's enough for the operators to look at only this. We can see that for this one here, we have a critical alarm. Here we can see that things are working well. Right now, we have a new batch. We have a transition between 2 batches. And so now it went from gray to green. And then for this particular unit, we don't have anything running in at all, so it's gray. So this one is a continuous process. So let's look at this one. I can actually now double click on this point. It brings me into that unit, and I can see what is causing my alarms. Here with this red X, this is where basically the alarms are starting. And the X is going to show where we first see the alarm. So then I can double click on that, or somewhere later, and I can see in this particular USP file we have a lot more variables. So here is one that is different, and we can double click on that, and now gets into the univariate space, and we can see exactly how that variable is behaving and where it went out. Good, and here we can see what, let's take this one, yes. This is the so-called worm plot. So this is Simca Online running for a continuous process. For a continuous process where we don't have a batch trajectory per se, but the process is running in steady state for a continuous process, of course. And that's why we have the Hotelling's ellipse, which is then defining the normal operating space of the process for a continuous process. And you can see how the process is running here. It's continuing its trajectory. And this one actually has a control model also associated with it. And if we have an outlier in a continuous space, process space, we can again double click on that from here. I can get my pointer right, yes, and get into all of the different variables which are that have been built into this process model, and double click on that to get into the particular variable that's causing the deviation. Good. So I also want to mention that these projects, of course, and configuration here, and sort of the finish of Simca Online, and how well these alarms are going to be fine-tuned depends on the configuration of these projects. And that's a big part of understanding of how Simca Online works, so we're going to take a quick look at that. So going to the project administration menu of Simca Online, I can then open up now, for example, the configuration that I have running for my batch process for Baker's Yeast. So I right-click here and I can say update configuration. It's running right now, so I can't really change it, but I can show you guys how the setup behind pulling data in. So first of all, we configure the different units, the different physical units, and all of this is based on first starting to upload a USP file. That's the baseline for creating one of these configurations that we have running here, is to upload a USP file that characterizes the process that you want to monitor. Then we build basically the different units that this model needs to characterize. we specify face conditions, and this can be then batch identifiers coming from either the batch table wrapper or from your historian. You specify the tag, which contains the batch ID, and then you specify the face tags. So if you have, for example, OSI Pi, then you will be able to drill into the different tags in Pi, and then you're going to have the IDs from the model file, and then you can just go in and double-click a particular on a particular variable to connect its variable in Pi with the name of that variable in the USP file. So this is basically how the connection between Simca Online, like the core of the connection between Simca Online and the process historian, in other words, and the process. And Simca Online is read-only. It can also go back and write. It's possible to write to the historian, but it's not going to modify any of the data that is residing in the real-time or the historical data buffer in the historian. You can then also, like I mentioned, configure all these different alarms, which these basic green, yellow, red operating principles are running on. You can have both multivariate alarms as well as univariate alarms. You can configure your alarms and target limits on individual parameters and add that together with multivariate alarms, which is something that we of course recommend to use T2 range and DMODX in combination, particularly together with an important score, and define alarms for those. You can then also have certain smart setups where you can specify how many observations you want to have outside consecutive in a row in order for an alarm to get set off, and how many total observations outside of the limit within a phase. All of this we can work with together to make the these alarm colors and these basic operating principles of green going to yellow, going to red, to make that just right so that we catch everything that we want to catch, and that's so that we also don't get false alarms. So this is what the system administrator works with, usually those that know the model well. And finally, I also want to show you that in the batch mode of Simca Online, besides looking at the contribution, it's all, or the batch evolution, you can also look at batch level plots. And so we can go in, and this in the batch level is where we look at if we have regression models that are running in batch level in the USP file of predicting perhaps final amount, which is in this case your final yield. You can see the predicted value of yield in the batch level. And you can also, if that is available, see the actually observed value, which we do have in this particular project. We have the observed values also field, so we can see how well the prediction is working. As you can see, it's working quite well. So we can see the prediction here of a critical, final critical quality attribute amount in the different batches that run along. Okay, so that was a very quick demo of Simca Online, and now I'm going to go back here and finish up with a few case studies or a few user testimonials from different customers that are working with Simca and Simca Online. Lanza is a company that works with Simca Online and uses it for multivariate online batch modeling and monitoring. In this case, average yield of the process was lower than expected. And you can see that. I'm going to take my pointer out also again here. You can see here in Simca, you can see batches, and some of them are sort of above the process window, and that would be the low yield group. So they had a high variation in yield here, and this was it became a difficult situation for them to plan work and to deliver to the end customer. So for this, they did a variability analysis using Simca to understand what caused this variability in yield. And with that, they were able to actually correct and make the yield higher and also more consistent. And then they employed Simca Online to monitor that process in real time to make sure that it stayed in that ideal space. That's Lonsam. Another example is Novartis, which actually have been utilizing Simca Online for a long time for real-time root cause analysis, multivariate modeling, monitoring and root cause analysis, as well as parametric release. And they have done a lot of work also with model validation, which is a very important concept in, of course, employing these types of models in real time. You need to model your process and then validate that model with both good as well as bad batches. And Novartis has done a lot of work with that, of course, since they are utilizing this for parametric release. And with that, they have achieved, among other things, an improved process consistency. And they've also realized that not all out-of-control incidents actually impact quality. Some of them do, but not all of them. And this enables root cause analysis for them. Origin IDEC is another company that have used Simca Online for a long time in their manufacturing environment. They use this to for scale up and comparing different scales. Simca and Simca Online can be good for that, particularly Simca. They use it for evaluating batch consistency and to analyze the relationship between all the measured process variables. That's sort of an offline activity. And then, of course, to compare the current batch in real time against the golden batch trajectory. So this is the real-time fault detection and root cause analysis. And for them, this has been deployed to multiple sites. It has improved the real-time fault detection to prevent deviations, and it's improved process and equipment knowledge. And they actually have site-wide acceptance of this tool with large LCD monitors that they have that display their process through Simca Online real-time trends. And that's the picture that you're seeing right here. And Amgen is another company that uses Simca Online, and Amgen also uses the Control Advisor. And they use it to improve yield and throughput on a bioreactor. And this is basically on an already optimized process where they use the Control Advisor. And with this, they've been able to improve viable cell density with 23% and improve the throughput with 20%. Quite good. They have also used Simca Online in the regular mode for a long time. That basically allows them to focus on the trends instead of gathering and charting data. They can focus on the data as it's presented by these trends and basically go straight to what it means for the process, and saved a lot using Simca Online. So, in conclusion, Simca Online is a market-leading tool for real-time multivariate monitoring and prediction. It is powerful based on its core science and method of multivariate methods, and it's also a tool which has been on, which is very powerful because it is user-friendly and it is suitable for implementation on the shop floor. It's got very powerful graphics, and it is a fully validated off-the-shelf software. It's suitable for GMP environments. And together, these features, that it's user-friendly, it's fully validated, it's off-the-shelf, it's been on the market for a long time, really can make a difference when you want to implement a tool like this on the shop floor in a GMP environment. And really where these applications, in order for them to make a difference, they there can be small differences in terms of refinement of the tools that can make a big difference in terms of how well and how successful the application is going to be within the company. And with that, I also want to again make another plug for the next webinar, which is upcoming on June 9, with my colleague Chris McCready, who's going to talk about the Simca Online Control Advisor. And with that, I thank you for your time and welcome any questions.
Anna, thank you very much for this fantastic presentation. Really, really nice to see all the capabilities of the Simca Online solution. Thank you so much. There are several questions and we will just very shortly be back to answer them. Thank you so much.